My name is Paul Manley with Zenith Private Payments, and today we're going to go through private AI solutioning with a concrete demo of underwriting in a workflow. We'll go over this in a few parts. We'll show an overview, some diagrams, we'll do a deep dive in technology, and we'll do a demo. We'll go over this in three big parts though: the business benefits, the technology, and we'll go into the underwriting workflow. One of your main business goals is that we want this to be fully owned and internal AI hardware. We don't want to send anything out of our network. We want to keep the security boundary intact, fully inside our scope. We also want to work on cost containment and cost centers. Tokens are expensive, and the industry is currently highly subsidizing the compute cost. That means in the future, we can expect the price per token to go up. Some big tech companies have spent their year's token budget in 4 months. Employees are token maxing to get interesting output. What's your budget per employee per tokens? Is it $100 a month? Is it $500 a month? We can recapture this cost with our own local hardware. You can run your private AI using your own hardware using open source models. Models are provided by Google, Anthropic, NVIDIA, OLM, and DeepSeek. The difference in cost is that you're paying an upfront cost for the hardware and then you're running it yourself. One of the greatest things about internal AI is that you never leave your security context, so you can call all your internal tooling, you'll have all your identity information, you'll have all your other services and your invocation inside your own ecosystem. You'll be calling your own services in the way that you're used to. For instance, if you have to do a document pull, if you have to update data, if you have to create events or ingest events, we can do that all internally without leaving your ecosystem. You never have to send data outside of your network. Your biggest gains are upfront one-time costs, keeping sensitive data internal, decreasing your security scope, and keeping your compliance needs negligible. Now let's go over the technical components of the solution. There's a few different moving parts that all kind of work together, so let's check them out. Your main one, that's part of the private AI solution, is your private classes of hardware. This is your hardware pool where you have to draw hardware from to run your models and workloads. Following that, you need a hardware connectivity manager that's going to check which hardware is available, which is in use, and what's ready. You also have your AI scheduler, where you enqueue work and then pull off pieces to actually do the work. You have your durable workflow manager, where you're actually running your workflow, not just AI workflows, but your general workflow. Those are all the steps that are necessary to accomplish whatever your task might be. And finally, you have your AI workload streaming, processing, and output loop. This is the actual loop that's running your text chunks and all of your other information. Let's go through each of these in a little bit more detail. Your hardware pool is the literal hardware. You should be tagging these items either queuable, free, cost, ones that are allowed to do different types of work. You may also want to tag the types of models you can do in here. For instance, some models do vision, some models do thinking, some models have text to voice. Your hardware connectivity manager is basically checking that all these are online, when they're in use, when they're available, and it's broadcasting that status information for the AI scheduler. The AI scheduler is there to ingest workload queues, so whatever work you might have to do underwriting, OCR this document, summarize this information. We put that into the agent work queue. When it's actually time to pull off this information, we check for available work. If there's available work to be done, we check for available hardware, which we have broadcast from the hardware connectivity manager. We pick the first server that's available that matches our tags and needs, for instance, queuable work, free, internal, secure, and a model that does vision, for instance. Then we actually start the work. That's actually making an open API or OpenAI API call and start streaming the events. We send that directly to the hardware that's running your front end. The thing that's actually doing the workflows and setting up these is your durable workflow manager. When I say durable, what I mean is that if you restart, it should pick up where it last left off. This is running a set of activities. An activity can be summarize a document, OCR something, read information, go pull credit, whatever you might need to do to accomplish your workflow. In this case, we're doing underwriting workflow, very common. OCR documents, pull lease information, pull deal information, pull guarantor information, do a credit check. All these are activities. These activities run in a sequence. You can fan out and then pull them back in. We're using Temporal IO Durable Workflow Manager. That's actually keeping track of the work and doing the activities. It's doing this in an event sourcing way where you're sending in lambdas that have inputs and you're getting back your output. If it's seen the activity before, it can just rerun it and it'll pull the event that's already happened, so it replays to get to the current spot. Included in here, it's running activities. Some of these are very long-running activities. Since we're running our own hardware, we're not always sure if it's available. When you're using OpenAI or Anthropic, typically they have lots of hardware that's available. We may be more hardware limited, and you have to queue the items. When you queue an item, you basically say, let's kick off an AI task. It might take a few minutes. It might run immediately. We're going to wait for it to either error or complete. So there's kickoffs, and there's signals that complete. Once you've completed the workflow, you return the full status. Now, the actual streaming loop is pretty standard. We're going to start with whatever information you might have. You might have a document, you might have image data, you might have a voice file. You want to start with that info, send it into the LLM. You want to basically alert that the hardware is now unavailable so that the AI manager can take that out of rotation. You want to kick off a event started. You want to kick off your heartbeat manager. And then you're going to start receiving chunks of responses. Those responses are sometimes text, sometimes that's still thinking. Sometimes we're making MCP service calls. Sometimes we're making internal tool calls. Sometimes it's just thinking and it's not doing anything, or at least not returning anything. We're going to send events as these happen. Whenever we're done, so whenever it's fully completed its loop, we're going to get the full response and send an event saying I'm completed. We're going to put the hardware back into rotation, and we're going to signal the caller that we've finished. In this case, the caller is probably our durable workflow manager. Our sample scenario is underwriting workflow. We're going to work on this through the durable workflow manager provided by Temporal IO. It's actually composed into two workflows, a main workflow for underwriting and then a sub-workflow for summarizing documents. Let's go through the sub-workflow first. Summarize documents has a few steps: reading in the data, preparing the image, getting the data directly if it's a text document, or OCRing the text if it's not. Once we have the information that's in the document, we need to use AI to summarize it for us. Once again, we use the workflow manager, we enqueue the work, it goes onto the AI scheduler. When it's time to actually do the work, it'll be pulled off and work into our normal streaming loop. Eventually it'll output text events until it's completed. When it's completed, it'll fan back in. We're waiting for our long running activity to finish. We'll save a summary, then we'll emit a completed event so that it can return to the main workflow of the underwriting process. The main underwriting process is to pull our lease or deal data, check if our credit details are available. If they're not, we'll pull internal tooling to go get them. Once they're available, we'll pull our credit document. We'll get all of our documents list. All of our documents list includes driver's licenses, business licenses, contracts, Google Maps, any web search information. Then we're going to go call the sub-workflow for each of those documents. We'll fan that out. We'll return that information back from the sub-workflow. Then we're going to use AI to summarize and do decisioning on the full information that we've received. So all of our credit documentation, all of our deal documentation, all of our business documentation. Again, that goes on the AI scheduler. We'll enqueue the work. Once it's pulled off, we'll do the work. We'll be streaming out the results. When we're done, we'll do a completed event. Once that comes back, we're going to save that as an AI summary, and we're going to turn the whole AI summary back to whoever's calling this workflow. And that's our basic underwriting workflow scenario that we're going to be doing with AI later. Let's run through one of the examples of underwriting using our own private AI solutioning. This is an example portal in demo mode. Let's go through and find an application that we're going to underwrite. Here's the application with lease information, deal information, guarantor information, and documents that need to be worked on. Now let's go to our sample underwriting page. Let's kick off the underwriting. As you can see, the steps we had defined earlier, we're mainly starting by OCRing documents and then summarizing them. OCR is just part of our system. The summarization, though, is through our AI workload scheduler. You can see that we've set up many summarized document workflows. Not all of them have started yet. We're only running 3 hardware right now. So those are older hardware that's on our VPN, some are local in our office. And you can see they are producing text chunks as they're going through and summarizing the documents that we've already OCR'd. Some of them are still pending work. There are 3 right now that are currently working. You can see all the text coming out as we're summarizing it. Once they're completed, it'll give the full summary. I'm only outputting little of the text chunks because we're streaming the output out. I want to give the user some kind of response. This is just an example of what you could do. You could make the UI better, but it's really important just to give the user some feedback as we're going. You can see here, summarization process completed, and then we have the completed information. This actually isn't important to show the user. What's important here is just that it's completed and that we're moving on to the next steps. Here's another document summary that also completed. Here's document summarization that hasn't started, but it has started accessing the hardware. If you want to see some of the technology behind this, let's go to our temporal workflow, and we can go see the steps that are being completed and haven't been run yet. You can see we have our total workflow that's happening, or at least underwriting workflow, and we have one document summarization workflow that's still running. You can see that it's still running. Looking at the actual technology part, here's our services that are running in C# that are doing all the actual work. You can see we're receiving AI workflows, we're getting data back, we're doing messaging to get the actual lease information. If we go back to our temporal IO workflow manager, we can see that it's completed some of the lease underwriting steps. If we scroll to the top, you can see that now our leasing underwriting decision step is about to start. You can see that we're still active, we're working on it, but we actually haven't gotten data yet. The stream is active. We're waiting for output because this is a big AI load that takes a minute to run. Here you can see we're starting to stream out all of our information. These are tokens coming out of the model directly through our AI service, then being sent through SignalR, and then those are coming up onto the leasing underwriting decision page. I can see this is HTML, which is what we wanted. We wanted a file solution that's visible to the user. It's streaming it all out. Once it's done, it's going to give us the final view. We can also look in temporal workflow and see what information or what workflows are currently running and activities. It's running the final one, which is just the main lease underwriting workflow. The AI scheduler is handling the actual work. And it's still sending out information to us. Here's our final result, our underwriting analysis summary for this company. Recommended conclusions, risk factors all highlighted. This is our kind of our final document with all the underwriting information we fed in, all the documents that I had to analyze, OCR, and summarize, putting all that together with our underwriting rules, looking for red flags and giving us, estimated risk exposure and giving us the final document we were looking for. Here's the final recommendation for this merchant. We've been running this locally on our own private hardware. We ran on my laptop. We ran over our VPN to some of our development hardware. We ran across some older machines. These models are provided by Google, provided by DeepSeek, and we've kind of run through a lot of this. But I just wanted to show you kind of a full working scenario underwriting private AI workflows all together to produce a result. Thank you.